Hello everyone, I'm Karthik and welcome to the fourth video in the series called Flip Supremacy, where we learn a lot of things about Flip. So let's get started for this project. So what I'm gonna do is I'll create a sim, a geometry network. I'll call it sim and I'll change the color here. Inside, what I'm gonna do is I'll create an alembic node so that we can bring in our collider, which is the cosmetic bottle. So let's start with that. So this is our cosmetic bottle, and I'm gonna use an unpack node here just to unpack the alembic into geometry. And then what I'm gonna do is I have transferred the path attribute. I'll create a convert node. So this convert node just is used just to make sure that everything here is polygon here. I'll use a attribute rename to rename our path attribute to name attribute, as name is the attribute that we assign to different paths here. So what I can do next is I want to place it properly. I'll use a transform node, so maybe we can give it a bit of rotation here in the z axis. So let's try something like this. Yeah, something like this. Yeah. And now what we can do is let's create our DOP source. There are going to be two DOP sources. Let's create the first one, and that's why I've created a sphere. So we'll use this sphere to create our DOP source. I'll just move it up a bit. Something like this. Yes. And this sphere is of size uniform scale 1. I'll change it to polygon. I'll increase the frequency to 10. So we have our first DOP source. I'll just change the size of this here. Maybe 0.5 will work fine. Yes, it is nice. I'll also change the size of the sphere here. So let's change it to 0.5 as well. Just like in my previous tutorials, I just wanted to tell you that the size of your scene matters here in Flip, especially when you're doing the small scale Flip simulations. So that's why I try to keep my whole scene size closer to 1 or 2 or 3 meters. So that's why the sphere here is half meters, and this will work nicely, I think. So what I'm gonna do now is I just want to make sure that we have got the face of our main bottle correctly here. So what I'm gonna do for that, I'll use a UV quick shade and I'll apply the texture that I'll be using in my final render. So just do that, label, and yeah, this is it. I'll just use a transform node. So I don't want to change anything here, so I have kept a transform node here. So now I can rotate it in the z, in the y direction, and this is what I'm getting. Yeah, this is nice. We can turn off of a UV quick shade. We don't need it anymore. What I'm gonna do now is I'll just take my sphere. I'll just template this. This is our sphere. Let's create our flip source. So I'm create a flip DOP source node. What this will do is it will provide us with a VDB value, a VDB container here, and some VDB here, and then particles here. We do not need any surface, VDB surface, so I'll just use a blast node to delete the surface. All right, we just need the particles. Out of this, I'll just create a null. I'll call it flip out. Okay, so this is our flip. So this is our flip node, flip source. What I can do now is I can create DOP network where we will set up our flip solver or nodes for our flip solver. So let's create a DOP network here. Let's get inside. I'm gonna create a gravity for gravity. I'll create a flip solver. I'll create a flip object, and I'll also create a volume source. Okay. We'll come to a flip object. You will see that we are getting some particles here, some points here, which are actually visualized as sprites. We'll first come to the visualization, change it to particles. So whatever particles we bring here will be visualized as particles, not sprites. What I can do for now is I just copy this, I'll paste it here, and usually there we should be okay. So this is our SOP path, and these particles that we have created here should be visible inside our DOP network, but they are not for some reason, and I think the reason for that is I connected a volume source here as well. No? Okay. What we can do is we'll come to our particle separation here. If I decrease the particle separation here, we will have a lot more particles in this volume. Okay, and what we want basically is the particle separation here. The particle separation here should be equal to the particle separation here. Oh, the reason I was not able to visualize our particles here was this. So I'm gonna keep this here, the mistake that I did here, so that you also, if you ever occurs, if something like this ever occur to you, then just make sure that you have particle field here, not surface. Okay. So these are the particles that we have. The particle separation here needs to be matching with the particle separation in this flip source here as well. Otherwise, what will happen is, let's just say, delete the channels here. Let's just say that I kept the particle separation to 0.01 here, and the total amount of points that I have here are almost 60,000. But if I come to particle separation in my flip object and I keep the particle separation bigger here, even though on the first frame we can look that the amount of particles seems same, but if I play the simulation, you will see that suddenly on the second frame the particles are reduced, and that is happening because the particle separation here has a different value than the particle separation there. So just copy this and come to flip source and paste it here, so that paste relative reference, so that the particle separation are always the same. The voxel size is usually the double the size of particle separation. So I'm just pasting the particle separation here as well and just multiplying it by 2. I'll connect my source here in the sourcing or the flip solver. Without the volume source, what is going to happen is I'll just come to flip object and I'll close the boundaries here of our volume domain here. You can see this is the domain that we have, and if you want to change the size here, you will come to flip solver, come to the volume motion and change the size here. I'll keep the size by 10 by 10 by 10. and I can change it to 10 here as well. I'll move it up a bit, something like this. Okay, and now let's run this. And as you would see, when we don't use the volume source, we are going to get just the one-time emit of the particles. What if you want a continuous emission of the particles here? And for that, we are going to use volume source here. Come to the volume source, change the initial to source flip. Change the, put the SOP path here, the same one that we have used earlier. I'll copy the SOP path, flip SOP, paste it here. And now when I run the simulation, you will see that we are getting a continuous SOP path, a continuous flip simulation. Right? It's like a tap water. Continuous fluid emission. And this is nice. What we can do now is I'm going to use a merge, and we can bring in our static object, which is our collider. Come to the merge and keep in mind that the affector relationship here should be mutual. I'll come out, come to our collider here, create a collision source, and come to the volume, and the voxel size here needs to be quite low, because if you visualize, the collision source gave us polygon collider, polygon geometry, and it also gives us volume. And this is the volume that we are getting currently, which is quite low quality. So I'll just decrease the voxel size here to something like this, 0.025. And you will see that in the polygon we are getting our whole geometry, but in volume we are only getting this. And the reason for that is this cap thing here doesn't really have any volume here. It's just a plane basically. So I'll use a poly extrude, and what I'll do is I'll select this cap and I'll increase the distance here. So the distance that we can keep here is something like 0.2 only, something like this. And we can also give the division here. If I don't give an addition, then this is what it is going to look like, but I would like to give some division here. Okay, and now if I come to the volume here, you will see okay, come to the poly extrude and turn on the output back, otherwise you will not be able to see the volume here. Okay, otherwise it was still plain. Come to the poly extrude and you will see, if I just look at this, you will be able to see it more clearly. So this is our cap. I've used a poly extrude here. If I turn off the output back, then there's no back here, it's just a basic plane. Okay, and there's no volume, that's why it's looking bad in our volume here. So just come to poly extrude and turn on the output back, and you will get polygon faces here as well, and then we can create volumes for our cap here. And it's looking nice. As you can see, we can go to our flip solver, go to the static object, go here, select our polygon swap path for our polygon and come to the frame one, and now you can see that our collider is in the simulation. We also want to import our volume collider. Come to the RBD solver, change the mode to volume sample, and here change it to volume. Okay. Here just use the volume path. If I play this now, let's see what we are gonna get. Okay, very well. So what is happening now is this is our continuous fluid simulation, which is a fluid emitter, and it is colliding with our collider, which is our cosmetic bottle here. Now we need to give some other attributes to our fluid emission so that it looks better. We also need to give some specific forces to our fluid simulation so that it works properly, and we also need to create another source here, as you have seen in the example. So let's do that now. Alright guys, so this was the preview for the third tutorial in the series called Flip Supremacy. You can join the course if you are interested in learning about flip simulations of different kinds. I'll be covering about 25 tutorials in this series, and for the first 20 students there's a discount. You can get the course for $85. So see you in the course.